Class 12, class 12, this is physics. Again, class 12 physics, all these are concept. I am dealing with concept. So here you see that, let us take, this is a magnet north, and here this is the south. So a coil, here this is the coil, here this is the coil. This is the coil. So now your current is flowing here like this, I current is flowing through here. This is the axis. So here you see current is flowing like this. Here you see the direction of the magnetic field is this. This is the direction of the magnetic field. And the direction of the dipole moment, that is M. That means it is means towards the into the plane of the paper. You can say that it is into the plane of the paper. Into the means it is like this. Here, this is the coil. So this, and here this is the magnetic field. Magnetic field. And now your torque will be perpendicular to this. This is your magnetic field. You consider it like this. This is your magnetic field. Here, this is your magnetic field. This is the dipole, direction of the dipole moment. Because the direction of the dipole moment, it is perpendicular to the loop carrying the current. So your torque will be in this direction. This will be your torque. Because torque is perpendicular to both the magnetic field and the dipole moment. Means it is somewhat like, it is like this. That means if you consider this as a plane, so this will be like this. So your torque means this is your coil, this is the plane of this coil. My hand, this is the plane of this coil. This is your plane of this coil. So your magnetic field is in this direction, and the torque will be in this direction, perpendicular to both the magnetic field and the direction of the dipole. You must remember that the dipole, its direction is perpendicular to the coil carrying the current, and this coil carrying current, it becomes a dipole, magnetic dipole moment. It becomes a magnetic dipole moment, this coil. So your torque will be in this direction. Your torque will be in this direction. Yes, let me explain it again. So this is the plane. Here these two are the north pole and the south pole. So here this north pole and this is the south pole. This is the plane. So direction of the magnetic field is this, and your direction of the, this is your direction of the magnetic field, and the direction of the dipole is in downward direction. So your torque will be in this direction, means perpendicular to both magnetic field and the dipole moment. So if you this figure becomes like this, so your magnetic dipole, direction of the magnetic dipole is in this direction. Here, this is the magnetic field. So now in this direction, so your torque will be in this direction, Torque will be in this direction. You first consider it like this. So here you see that this is the plane, and here this is the north pole, this is the north pole, and this is the south pole. This is the magnetic lines of forces, this is the magnetic field direction, and the direction of the dipole will be downward. Here you see downward. So the torque will be in the direction this, perpendicular to both. The torque will be in this direction. Now if you make like this, see it becomes like this. So torque direction is downward. This is the torque direction. So here the direction of the torque is this. So torque that will be equal to magnetic moment cross V, magnetic cross V, magnetic field. So in magnitude it will be MB sine theta. Theta is the angle between the magnetic field and the dipole moment. Theta, it is the angle. Now why I have selected this here, the reason is that it is like, it is analogous to electric dipole, where this is your torque, is electric dipole moment into cross electric field. Here the net force will be 0, and the here also net force is 0, and the magnetic, here the electric field will produce a torque which will either align this dipole in the parallel or anti-parallel to the electric field. Here the same case, it will align it in the direction parallel or to the magnetic field, and when it becomes parallel to the magnetic field, your theta is equal to 0. So this is a stable condition. Stable, we say that it is in a stable equilibrium. Stable equilibrium. So now what I want to tell you, why I tell you that, for problem, from the point of view of problem. Now suppose if because this is the torque, so and there is a rotational effect, so here torque, we know that it is moment of inertia into, that is angular acceleration. This is torque, this is called moment of inertia into angular acceleration. So here, because there is a rotational effect, so these two are linked. So these two can be linked here. So these two can be linked here. So when we link these two, what happens? That is, when we link these two, your I, angular acceleration, that will be equal to mb sine theta. So here we see we link here. So what will help this? By the help of this, a question may be asked for you from a, what will be the angular speed when it is rotated through an angle of 90 degree. What will be its angular speed? Such type of questions it can be asked. So here I want to tell you that this torque is related with this torque. That is the rotational effect which you have learned in class 11. So here again you see that angular acceleration, that means d omega by dt, that is equal to mb sine theta. Now from here you see that what happens, that is we can write this in the form of chain rule, d theta by dt, that is equal to mb sine theta. Now here you see that I d omega by dt, this is angular speed, this is your angular speed or angular velocity, which is omega, and that is equal to mb sine theta. Now this is theta, this is theta. So here I omega d omega mb sine theta d theta. Now if you integrate it, that means you want what will be your final angular speed when it is rotated through 90 degree. So 0 to pi by 2. Here you get I omega square by 2, 0 to wf, and this will be mb minus cos theta, that is 0 to pi by 2. So this comes here like this, I omega f the whole square by 2, that is equal to mb cos theta. So omega f that is equal to mb cos, this will be only mb because cos 0 is 1. So mb by I root over. So here, see, we got a relation that we can find the angular speed of this coil when it rotates to a 90 degree. So this is the concept why I have taken this, because when there is an angular moment, then these two comes into link. And when this comes into link, that means a question may be asked, what is the angular speed of the coil when it is rotated to some degree. So here you get this equation. So what I want to tell you, such type of questions are asked in your competitive examination, or it may be also asked in your board examination. So when theta is equal to 0, that means the coil is parallel to the magnetic field, then it is in a stable equilibrium. Now let us take another question. Another question here. Let a charge q, just draw, this is y axis, this is x axis, and this is z axis. Now let a charge q moving with velocity v in y axis, and an electric field is applied in the y direction. Here this is the electric field is applied in the y direction, and the magnetic field is applied in the z direction. This is your electric field applied in the y direction, and your magnetic field is applied in the z direction, and a charge q with velocity is moving in x direction. So the electric field force will be in the direction of the field. It will be in the direction of the field. But the magnetic force, we know that F magnetic force is equal to Q V cross B. So your force will be perpendicular to these two forces, V cross B. So the force will be in the downward direction. FB, this will be your magnetic force in the downward direction. So here you see that the net force will be on this charge will be F net force. This will be let us take in this way, that is the electrical force Fe electrical force, it is acting in y axis. So Q E J cap, this is your electrical force, and your magnetic force, it is so here you let me see. So again your velocity, it is in V I cap direction, and your magnetic field that is in B J cap direction. So here this will be Q V I cap cross B J cap, that means I cross J, you are going to get Q V cross B sorry, J, this is B is K, this is K cap, so K cap, so I, J, K, so here I into K, it will be minus J cap, so this will be minus Q V cross B, that is J cap. So your magnetic force FB, magnetic force will be minus Q V cross B J cap. So here you see, here this will be F B, this will be minus Q V B J cap, because V B, it is, remove this cross, it is better, right, V B. So this will be F Q V B VB J cap. So here your total force F will be equal to F E and this plus FB. So here F is Q E J cap minus Q V B J cap. So this is equal to Q common E minus VB J cap. This is your F force. This is your F force. Now if we take the magnitude, so this will be F is equal to Q E minus VB. This will be your magnitude force. Now here, if your this electric force and magnetic force are equal, that means if they are equal, if your magnetic force and electric force are equal, so your F will be equal to 0, and when F is 0, that means V will be equal to EV equal to 0, so V will be equal to E by, so V will be equal to E by. So the most important point here is that V is equal to E by B. That means a charge whose velocity is equal to E by B, a charge whose velocity is equal to E by B, a charge whose velocity, it will move in the x direction undeflected. It will move in the x direction undeflected. So here again questions can be asked that to find the velocity when the charge moves undeflected. So here again a question can be asked to find a velocity which moves undeflected. So this is your result. That means your velocity must be equal to E by B. Your velocity must be equal to E by B. So this is another concept. Such type of questions, simple questions, can be asked in your competition or also in your board examination. So to find a velocity where the means of charge is subjected to both an electric and magnetic field. Electric field and magnetic field are both perpendicular to each other. So what will be the velocity of the charge so that it moves undeflected? So the velocity for your calculation E by B, say, and like MCQ, and such type of questions will be asked. And this is your theory, because direction this. So here it comes to be I cross K. This is Ij, Jk, Ki. But here since it is Ik, so it is minus J. So your magnetic force is minus, and the total force is this much. So here, if this electric force and magnetic force are equal, then your equal, that means F is 0. So F is 0 because here F, it represents the difference between the two forces. Algebraically it has been cleared. That the net force is the difference between the two forces, and if this force is 0, that means electrical force and magnetic force is 0. So your V, that is the velocity of the charge, will be E by V. So in this way, you can question may be asked. Such type of conceptual questions may be asked to when a charge is subjected to both electric and magnetic field. So, and the electric field and magnetic field are perpendicular to each other. What will be the velocity of the charge so that it moves undeflected? So, such type of problems it can be asked in your competition or in your board examination.